Okay, so we're going to try to find the volume of the upper half of this ellipsoid. And we're going to try to do it in the standard way first. But this video is really going to be about polar coordinate transformation, but I want to try to do this problem in the standard way, and then we'll try it using a coordinate transformation and see that it's much easier if we do a transfer into polar coordinates, okay? Okay, so now if I was going to do this problem, I already made the decision. All right, so this is the ellipsoid, but if I do the projection of that guy onto the xy plane, because remember, we have an f of xy, okay, that's that z right there, that we're going to try to integrate across a domain, okay? And so if I'm considering the domain just within the xy plane, what is it? It's a circle. So if I set z equal to 0, I get that x squared plus y squared is going to equal 4, all right? And so if I solve for x, saying, all right, this is plus or minus the square root of 4 minus y squared. Right. And so I already drew my arrow for integrating in the x direction, and I created x as a function of y. Okay, so let's set up this integral. Okay. So if I want to begin in the x direction, right, in the y direction, I'm going to go from -2 to +2. So that'll be the integral from -2 to +2, and the integral of negative root 4 minus y squared to positive root 4 minus y squared times 4 minus x squared minus y squared. Now this is dx dy. Okay. Well, what would this become? This would become the integral from -2 to 2 of 4x, now minus x cubed divided by 3 minus x y squared. And now this has to be evaluated at the negative square root of 4 minus y squared times the root of 4 minus y squared y. Okay. And so that would become the integral from -2 to 2 of 4. Okay, now this would be 4 minus y squared minus now -4 root minus y squared. And then minus, and this would be negative root 4 minus y squared, and then cubed divided by 3, sorry, that's positive. And then minus, no, that would turn into a plus, and then that would be a negative root 4 minus y squared, and then cubed divided by 3, and then minus, now root 4 minus y squared times y squared, and then plus of a negative root 4 minus y squared times y squared. And if I solve for all of this, what is this going to come out to be? This is going to be -2 to 2 of 8 root 4 minus y squared minus 2 divided by 3. And that will be 4 minus y squared to the 3 divided by 2. And then minus 2y squared root 4 minus y squared dy. Oy. And then what would I have to do? Your only option on this problem is then to say y would equal 2 sine theta, and to make a trigonometric substitution. So this problem is pretty nasty. And so when looking at this problem, this is like, if I try to do it in the standard way, it turns into a gigantic mess, okay? And eventually, I'm going to have to do a trig substitution anyway to even try to figure this out. So, when you think about a problem like this, you're gonna get stuck with the trig sub anyway. Why don't we just consider this problem is dealing with a circle? Okay? So, if it's just dealing with the domain being a circle, why don't I do a transformation into the polar coordinate system? Okay? So if I do a transformation into the polar coordinate system, okay, if I consider a region and I'm dealing with an f of xy dA, this will actually equal the integral from alpha to beta of the integral from a to b of f of r cosine of theta r sine of theta. Now r dr there. Okay? And that R right there is important. We'll talk about this later on, but it actually comes from the Jacobian. Okay. And so we have to consider, well, what is the alpha and beta, and what is the A and the B? Okay? And so we consider this, R will actually equal the region, okay? Now this is going to be r theta, where 0 is going to be less than or equal to a, which is going to be less than or equal to r, which is going to be less than or equal to b. So we're not counting negative radiuses, okay? The reason for that 0 right there is you're not going to go, when I draw the circle, you're not going to go from negative r to r. You're always going to go from the center outwards, okay? And alpha is going to be less than or equal to theta, which is going to be less than or equal to theta. Okay. So the radius always has to be considered positive, but you can think of the negative there. So what would the region, let's consider our circle that we were looking at just a second ago. 1, 2, 2. So we have that x squared plus y squared is going to equal 4. So if I'm describing this region, probably run out of room, but oh well. Okay, so let's consider for this circle right here. Okay. Now, instead of describing this region in terms of x and y, we're going to describe this region in terms of r and theta. So if I consider the radius has to be positive, okay? Well, what is the radius going to do? It's going to go out from 0 to 2. Okay? And so 0 is going to be less than or equal to r, which is going to be less than or equal to 2. Okay? Now, if I consider my theta, so r is going outwards, but theta is a rotation. So if I start here at 0, we're going to encompass a full rotation all the way from 0 to 2 pi. Okay? So 0 is going to be less than or equal to theta, which is going to be less than or equal to pi. Okay. So, to calculate this, okay, so the original function was 4 minus x squared minus y squared. And so we have x equals r cosine theta, and y equals r sine theta. Okay? So, the double integral along that region of 4 minus x squared minus y squared a, okay, is going to equal the integral from 0 to 2 pi of the integral from 0 to 2 of 4 minus r cosine theta squared minus the constant parentheses on this is definitely squared by r. And this is the r sine theta squared. And then r dr d theta. Okay. So, how can I simplify this thing? Okay, now both of these guys have an r squared on them. So, we write this, the integral from 0 to 2 pi, but the integral from 0 to 2. Alright, so that's 4 minus r squared times cosine squared theta plus sine squared theta and r dr theta. Now remember, all the way back from trigonometry, what is sine squared plus cosine squared? Well, sine squared plus cosine squared equals 1. So one of the good things about making this transformation into the polar coordinate system is that, yeah, we can use our trig identities. And since you see that this was in relationship to a circle, you're going to have cosine squared plus sine squared equals 1. Okay? So, where does this put us? That puts us here. The integral from 0 to 2 pi, the integral from 0 to 2 of 4 minus r squared, now r dr d theta. Okay. All right. So now instead of what we were going to do on the last method was going to be like a trig substitution once we got down to trying to solve the thing. What are we doing on this one? We're doing a u substitution. Okay? So I see that I've got 4 minus r squared and I've got that r dr right there. So ignore the 0 to 2 pi and the d theta, and let's just consider we're dealing just with this inner integral right here. Okay? And so if I let u equal 4 minus r squared, that means that du would be negative 2r dr. Okay? Or that du divided by negative 2 equal r dr. Okay. And now remember, when you make a transformation, I mean a u substitution, your boundaries need to go with you on that substitution. Okay? So if I plug 0 into this u, which equals into that r right there, what is that 0 going to become? That 0 is going to become a 4. Okay? If I plug 2 into that thing, I'm going to get 4 minus 2 squared. So the top term is going to become 0. So this thing becomes the integral now from 0 to 2 pi, and the integral, all right, so 0 plugged in is 4, 2 plugged in is 0, okay? And now we have u, which is a 4 minus r squared, okay? Then the RDR, this guy right here, is going to be replaced by du divided by -2. Okay. Uh-oh. My boundaries are upside down. Now ignore the integral with respect to theta. Okay. Just imagine that we're dealing with the integral with respect to u. Okay. So remember all the way back, well, not long ago, calculus 1. What can a negative sign involving an integral actually do to the boundaries? Okay. Well, the integral from a to b of f of x with respect to x is equal to the negative integral from b to a. Okay? We got this extra minus sign right here. So that what that's going to allow us to do is that's going to allow us to flip our boundaries upside down. I didn't think you'd have to remember these rules. You do. So this becomes the integral from 0 to 2 pi. Now this would be the integral from 0 to 4, now of u divided by 2 du d theta. Okay, so now we just have an integral of u divided by 2 with respect to u, and we got our boundaries already. Okay, so I can integrate that u, which is going to become u squared divided by 2. So that becomes, well, let's leave these alone, 0 to 2 pi. That becomes u squared divided by 4, evaluated at 0 and 4, and we still have that d theta. So, okay. Now if we plug in 0 into this problem, it's just 0. Okay? But 4 squared is 16. So this becomes the integral from 0 to 2 pi of now 16 divided by 4, an integral with respect to theta. And 16 divided by 4 is just 4. So this becomes for theta evaluated at 0 and at 2 pi. Okay? Now if we plug in 2 pi into this, we don't care about the 0 once again. We get to 8 pi. And so that is the volume of that ellipsoid by transferring into polar coordinates to actually make the problem. It's still kind of a tricky problem, but it's a lot easier than trying to do this in the standard coordinate system. And in general, if you see problems that are involving circles or ellipsoids whose area is a circle, then you want to think that it will be easier to transfer into the polar coordinate system to actually solve this problem. Okay?